Hello friends and welcome to YouTube channel on Engineering Mathematics by Dr. Navneet. Friends, in this video lecture we are going to learn the fourth method for finding the inverse Laplace transformation, which is called as inverse Laplace transformation by convolution theorem. So let's first define the convolution term. So first define convolution. So definition. If f1 of t and f2 of t are two functions, f1 and f2 are two functions, then integration 0 to t f1 of u f2 of t minus u du. So then this integration is called convolution. Is called convolution of f1 of t and f2 of t. So this is called as convolution, and we denote it as and denoted by f1 of t star f2 of t. So now in short we can write this as thus convolution of f1 of t with f2 of t is equal to integration 0 to t, then this is f1 of u into f2 of t minus u du. Friends, this is called as the convolution theorem. So this theorem is applicable when there are two functions. So this word 2 is important for the convolution theorem. Now let's this is the definition of convolution theorem. Now let's write down the theorem which is related to this convolution. So now next important point is convolution theorem. So now theorem. So we are defining here, we are mentioning the statement of theorem which is related to the convolution for the Laplace transformation. So this theorem says that let Laplace transformation of f1 of t, so Laplace transformation of f1 of t is equal to phi of s, and assume that Laplace transformation of f2 of t is equal to, this is suppose phi 2 of s. So these are the values of phi 1 and phi 2. Then this convolution theorem says that inverse Laplace transformation of phi 1 of s into phi 2 of s is equal to integration 0 to t, then this is f1 of u, then f2 of t minus u du. So where value of f1 of t is equal to inverse Laplace transformation of phi 1 of s and that of f2 of t is equal to inverse Laplace transformation of phi 2 of s. So this theorem is called as the convolution theorem for the Laplace transformation. So once again I will repeat the statement. So if we find the Laplace transformation of first function f1 of t, we denote this by phi 1, and again if we find the Laplace transformation of second function f2, let's denote this by phi 2. Then inverse Laplace transformation of phi 1 phi 2 is equal to integration 0 to t f1 of u f2 of t minus u du, where this f1 is obtained by taking the inverse Laplace transformation of phi 1 and f2 is obtained by taking the inverse Laplace transformation of phi 2. So this is called as the convolution theorem for the Laplace transformation. So now there is one process for solving the example based on this process. So let's write down procedure. So let's write down procedure. So we are discussing here the process of applying convolution theorem. So first step for solving any example based on this convolution theorem is that, so first find out the value of phi 1 of s and phi 2 of s. That means whatever given example is there, so let's split that example into two parts. Call first part as phi 1 and call the second part as phi 2. So this is the first step. Now after taking two values, so second step is find the value of Laplace transformation. So find the value of, so this function, inverse Laplace transformation of this phi 1 of s, and we denote this by f1 of t. So let's denote this by f1 of t, so which is also equal to f1 of u. So that means replace here t by u. So this is the second step. Now again third step is find the inverse Laplace transformation of, so find inverse Laplace transformation of phi 2 of s, and we get second value which is f2 of t. Again replace this t by, so replace t by f2 of t minus u. So that means replace this t by t minus u. This is the third step for solving example based on this convolution theorem. And fourth step is apply convolution theorem. So apply the convolution theorem. This theorem says that inverse Laplace transformation of phi 1 of s, phi 2 of s is equal to integration 0 to t, then this is f1 of u, then f2 of t minus u du. So friends, so this theorem is very simple, so it is very easy to solve the example based on this theorem. So this is the process for solving the example based on the convolution theorem for finding the inverse Laplace transformation. First step is that find two values phi 1 and phi 2, that is split given function into the two parts. First phi 1, second called phi 2. Then first find out the inverse Laplace transformation of phi 1 and call this as f1 of t, and replace this t by u. So variables are immaterial. So now again find out the inverse Laplace transformation of phi 2 and we get this as f2 of t. Again replace this t by t minus u. Then after that apply the convolution theorem. So this is the process for solving example based on the convolution theorem. So now to understand this concept, so let's take the first example so that your idea will get clearer. So first exercise, so example first, find inverse Laplace transform by convolution theorem. So find the inverse Laplace transformation by convolution theorem. So for the term, suppose this is 1 upon s plus 2 and s minus 1. Suppose this is s plus 2 and s minus 1. So we have to apply here convolution theorem. So now friends, only simple thing about convolution theorem is that, so for finding the inverse Laplace transformation of any function by convolution is possible when there are such type of two terms. That means when only two terms are there in a given function, then and then it is possible for us to apply the convolution theorem. Otherwise, use the concept of inverse Laplace transformation by partial fraction. This method we already learned in our previous video lecture. So watch our previous video so that you will get detailed idea about that. Now here, what the first step says that, so whatever given example is there, so let's split this example into two parts. So let's call first part as phi 1 and second part as phi 2. So according to this first step, we can write this as, let f1 phi 1 of s is equal to 1 upon s plus 2, and assume that f2 of s is equal to, this is 1 upon s minus 1. So now this is the first step, phi 1 and phi 2. So if we take the product of phi 1 and phi 2, we get the original function as it is. That means split the given example in such a way that after taking the product of this phi 1 and phi 2, we will get the original term as it is. Now this is the first step. Now second step is, step number 2, find out the inverse Laplace transformation of phi 1 of s. So therefore, inverse Laplace transformation of phi 1 of s, so which is equal to inverse Laplace transformation of 1 upon s plus 2. So now friends, this equation is in our standard form. So inverse Laplace transformation of 1 upon s plus a is equal to e raised to minus at, where value of a is 2. So we can write this as e raised to minus 2t. So now this theory part says that after finding the inverse Laplace transformation of phi 1, we get the first value, which is called as f1 of t. So this is the value of f1 of t. Now replace t by u. So after replacing t by u, we get this as e raised to minus 2u. So this is the value of f1 of u. So friends, this is our second step for applying the convolution theorem. Now apply the third step, find the inverse Laplace transformation of phi 2 of s. So now third step, inverse Laplace transformation of phi 2 of s, which is equal to inverse Laplace transformation of value of phi 2 is 1 upon s minus 1. So if we calculate this value, then again this equation is in our standard form number 2, 1 upon s minus a, which is equal to e raised to at, where the value of a is 1. So we can write this as e raised to t only. So now whatever equation we are getting, so this is the value of our f2 of t. So this is the value of our f2 of t. So call that value as f2 of t. Now replace this t by t minus u. So if we replace t by t minus u, we get this as e raised to t minus u, and this is the value of your f2 of u. So in this way we will reach to step number 3. Now step number 4 is apply the convolution theorem. So step number 4, by convolution theorem, so we can write this as inverse Laplace transformation of phi 1 of s, then phi 2 of s is equal to integration 0 to t, then we can write this as f1 of u, then this is f2 of t minus u du. So this is the convolution theorem. So in this theorem, so let's put the value. So we can write this as inverse Laplace transformation of f1 and f2. So sorry, phi 1 and phi 2. So phi 1 is this value, phi 2 is this value. If we take the product of this value, we get the original function as it is. So that's why we can write this as inverse Laplace transformation of s plus 2 and s minus 1, which is equal to integration 0 to t as it is. So put the value of f1 of u. So now f1 of u, its value is e raised to minus 2u. Now put the value of f2 of t minus u. f2 of t minus u is, so actually this is f2 of t minus u. So now we can write this as e raised to t minus u, then du. So friends, here we get integration. So now to solve this integration with respect to u, so whenever we are trying to solve this equation with respect to u, the term t is constant. So now take the term t outside the integration. So we can rearrange this equation as integration 0 to t, then e raised to t, e raised to, so power of e for the variable u is minus 2u and minus u. That means this is e raised to minus 3u du. So in this equation, so this e raised to t is constant because we are integrating with respect to u. So we can write this as e raised to t, then so integration of e raised to minus 3u is e raised to minus 3u upon minus 3. Its limit is 0 to t. So now friends, next step is to put the value of upper limit and put the value of lower limit, so that we will reach to the final answer. So upper limit is t, so replace u by t, we get this as e raised to minus 3t upon minus 3, then this is 1 upon minus 3. So because e raised to 0 is 1, so now after taking the term 3 common, so we get this as e raised to t upon 3. So this minus becomes, so we can take 1 upon 3 common. So now we write positive term first, so we get this as 1. So this is the 1 term. Then this is minus e raised to minus 3t. So friends, in this way we can easily solve the example based on the convolution theorem. So this is the first example. So let me once again revise this example. So whenever we are interested to find out the inverse Laplace transformation by convolution theorem, so very first step is that, so this is the first step, find out the value of phi 1 and phi 2. So this is the value of phi 1 and this is the value of phi 2, so that after taking the product of this phi 1 and phi 2, we get the original term as it is. So that means split the given equation into two parts, and after taking product we get the original function as it is. So now the second step says that find out the inverse Laplace transformation of phi 1, which is f1 of t, and replace t by u. So now here we find the inverse Laplace transformation of phi 1, so which is e raised to minus 2u, and we replace t by u, which is the value of f1 of u. Now third step, find out the inverse Laplace transformation of phi 2, which is inverse Laplace transformation of 1 upon s minus 1, which is e raised to t. So but this theory part says that, so replace this t by t minus u, we can write this as e raised to t minus u, which is the value of f2 of t minus u. Then fourth step is to apply the convolution theorem. So now here we apply the convolution theorem. So this is the convolution theorem. So we put the value of phi 1 and phi 2, which is the original function. So now f1 of t, so f1 of t means this is e raised to minus 2t, then f2 of t is e raised to t minus u. So after taking this term, so take constant e raised to t outside the integration, find out the integration of e raised to minus 3u, then put the value of upper limit, put the value of lower limit, we will reach to the final answer. So in this way we can easily solve the example based on the convolution theorem. So these are the four important steps for solving the example based on inverse Laplace transformation by convolution theorem. Now friends, let's take the second example. So example number 2. Now friends, let's take the second example. So we will discuss the second example. So example is find the inverse Laplace transformation of s square upon, suppose this is s square plus a square, then its square. So our aim is to find out its inverse Laplace transformation. So here we are interested to solve this example with the help of convolution theorem. So now let's do the first step. What the first step says that split the given example into the two parts. So we can write this example as phi 1 of s is equal to s upon s square plus a square, and let's denote the second value as s upon s square plus a square. That means we split this given example into the two parts, so that after taking product of these two parts we get original function as it is. So this is our first step for solving the example by convolution theorem. Now second step, find inverse Laplace transformation of phi 1. So if we find the inverse Laplace transformation of phi 1 of s, then we get this as inverse Laplace transformation of s upon s square plus a square, so which is equal to. Now friends, we know that this is the standard result. So inverse Laplace transformation of s upon s square plus a square, which is our standard result number 6, which is cos of 80. So we can write this as cos of 80. So whatever value we are getting here, we are denoting this value by f1 of t. That means we get solution in terms of parameter, in terms of variable t. Then this statement says that replace t by u. So if we replace t by u, then we get this as cos of au, and this is the value of our first function, which is denoted by f1 of u. Now third step is to find out the inverse Laplace transformation of phi 2 of s. So now if we try to find out the value of inverse Laplace transformation of phi 2 of s, so which is equal to inverse Laplace transformation of phi 2. So value of phi 2 is again s upon, this is s square plus a square, which is again same term cos of at. But this step number 3 says that we get value of f2 of t. So this is the value of your f2 of t. But here replace t by t minus u. So if we replace t by t minus u, then we get this as cos of a. Now replace t by t minus u. So don't write in this way. So this is mistake point. So we are replacing t by t minus u. So write down bracket for that value. So now this is the value of our f2 of t minus u. So now we will reach to step number 3 here. Now apply step number 4, which is called as convolution theorem. So by convolution theorem, we can write this as inverse Laplace transformation of phi 1 of s, phi 2 of s is equal to integration 0 to t, then this is f1 of u, then f2 of t minus u du. So theorem is given here also. Now in this theorem, put the value of f1 and f2 of t minus u and find out the integration. So this is same as inverse Laplace transformation of phi 1 phi 2 its product. So product of this term and this term is given example. So we can write this as s square upon s square plus a square, then its square is equal to, this is integration 0 to t, then put the value of f1 of u. So value of f1 of u is, so this value is cos of au. This value is cos of au. Then put the value of f2 of t minus u, which is again cos of a time t minus u du. So we put the value here f1 and f2 of t minus u du. So now next step is to find out the integration of this equation. So but friends, this equation is not in our standard form, because for finding the integration of any term, so equation must be in its standard form. So this is the product of two terms, and such type of standard formula is not available for evaluating such type of integral. So now next step, our next aim is to convert this given example in terms of standard formula. So now to convert this equation in terms of standard formula, we require single term. So here cos term is there, then we know that cos of a cos of b is equal to 1 upon 2, then this is cos of a plus b, then this is again cos of a minus b. So now this is the formula which is applicable here. So to find out this integration, now put the value. So we can write this as cos of au into cos of a time t minus u is equal to 1 upon 2. So now first take the addition of angle a and b. So here value of a is au, its addition with second term. So second term is a time t minus u. So if we rearrange this equation, then we get this as au plus this is at, then this is minus au. So this minus au plus au will get cancelled, and this angle is cos of at. This angle is cos of at, and this is plus again cos of a minus b. So value of a minus b is, so let's take the subtraction of these two angles. So value of a is au and value of b is at minus au. So if we take at, then this is minus au. So take the subtraction of these two terms. So after taking subtraction of these two terms, we get this as au, then this is minus plus 2 times au minus at. If we take a common, then we get this as 2u minus t. So this is the angle. So we can write this as a time 2u minus t. So this bracket as it is. So in this way we get this as the cos term. This is again cos term. Now we know that integration of cos term is always possible. So put the value of this term in this integration and try to find out the value of integration. So now here after putting this value in the given integration, we get next step as, so let's note down the next step. So we can write this as integration 0 to t. This is integration 0 to t. Then we can write for this term as 1 upon 2. Then in bracket we get this as cos of at plus cos of a time. This is 2u minus t into du, because we are integrating with respect to u. Now friends, according to the properties of integration, we can write this as 1 upon 2, which is common, so we can write here curly bracket. Then first integration is integration 0 to t, and this is cos of at du plus integration 0 to t, and this is cos of a time 2u minus t then du. So now because of the properties of integration, we write this into the two parts. So now after writing this into the two parts, next thing is that find out the integration. So now which is 1 upon 2, then friends here we are integrating with respect to u. Now this first term is cos of at. We are integrating with respect to u, and this term is cos of at. That means this cos of at is constant term because of integration with respect to u. So we get here as integration of 1 du. Integration of 1 du means u. So for adjustment we can write this as u time cos of at. So we write u first, so to avoid the confusion in the notation. Now this is the first term plus, now find out the integration of second. So u is present here, we are integrating with respect to u. So integration of cos is sine, so we can write this as sine a time 2u minus t. But angle is other than u, so we can take the derivative of a time 2u minus t, so which is 2au minus at. So we have to take the derivative of this term with respect to u. We get derivative of this term with respect to u as 2a. So that means we can write this as 1 upon 2a. Now here for this integration as well as for this integration, limits is, so here limit is 0 to t. Again for this term also limit is 0 to t. So now next step is to put the value of upper limit and put the value of lower limit. Now we will try here to put the value of limits. Now here put the value of upper limit, which is t, so we can write this as t into cos of at. Then if we put the value of lower limit, so minus lower limit is 0, u is equal to 0, so this first term is 0. Similarly here we can write this as 1 upon 2a as it is. Then put the value of upper limit is t. We are putting this upper limit for u, we get this as sine of, if u is equal to t, then we get this as 2t minus t, that means t, so we get this as sine of at minus. So if we put u is equal to 0, then we get this sign as u is equal to 0, that means we get a value as sine of a time minus t. So then we know that sine of minus theta is equal to minus time sine theta, so we can write this term as minus minus plus time sine of, this is 80, this is sine of 80. So now in this way we get this answer. Now next step is, so we can write this as 1 upon 2 t cos of at plus this is 2 upon 2a into sine of 80. This is sine and sine, we get this as 2 times. So now this 2 will get cancelled and we will reach to the final answer as 1 upon 2 t into cos of 80 plus 1 upon a into sine of at. So friends, this is the second example, which is simple and which is based on the convolution theorem. So here we solve the example, which is s square upon s square plus a square its square. Now if we change the sign, so if we replace plus by minus, then same example, only hyperbolic function will get appear in this example. So now friends, this is the second example. Let's try to solve the third example. So now third example. Now friends, let's try to solve the third example. So now third example is, so to find out the inverse Laplace transformation by convolution theorem, and example is 1 upon s square then s plus 1 its square. So now we have to solve this example by convolution theorem. So now first step is to find out the value of phi 1 and phi 2. So now here we will find the value of phi 1 and we are interested to find the value of phi 2. But friends, whenever we solve the example based on the convolution, so choose the value of phi 2 in such a way that that value must be simple. So now here first value is s plus 1 and second value is s. So we will choose phi 2 as s square. So why? Because in this phi 2 term, so after finding its inverse Laplace transformation, so we are replacing t by t minus u. So to avoid the complicated calculation, better way, choose the value of phi 2 in such a way that we get the calculation in simple way. So now that's why we choose the value of phi 2 as s square. Then phi 1 is, so this is 1 upon s square. So now we can write this as 1 upon s plus 1 its square, so that after taking product of these two terms we get the original function as it is. So now once again I will repeat here. So choose the value of phi 2 which is simple, because after finding inverse Laplace transformation of phi 2 we are replacing t by t minus u. So that's why choose simple value for phi 2. Now this is first step. Now second step is to find out the inverse Laplace transformation of phi 1. So inverse Laplace transformation of phi 1 of s is equal to inverse Laplace transformation of 1 upon s plus 1 its square, which is equal to. So now friends, we know that, so here 1 is added to the parameter s, that means we have to apply the inverse Laplace transformation by second shifting theorem. So already we have prepared such type of video. So my request to all of you is that for understanding this step, so please watch our previous video. So we can write this as e raised to minus t. So here 1 is added to the parameter s, so we can write this as e raised to minus t into, this is inverse Laplace transformation of 1 upon s square. So we can write this as e raised to minus t. So then this is our type inverse Laplace transformation of 1 upon s raised to n plus 1, where the value of n is 1. So according to this formula we can write this as 1 upon 1 factorial t raised to 1, or in simple way we can write this as e raised to t. So now this step number 2 says that, so whatever value we are getting in terms of t, replace t by u. So we can write this as e raised to minus u into u, and this is the value of our f1 of u. So this is our step number 2. Now let's apply step number 3. So step number 3 says that find out the inverse Laplace transformation of phi 2. So inverse Laplace transformation of phi 2 is equal to inverse Laplace transformation of phi 2. Value of phi 2 is 1 upon s square, so which is equal to, again this equation is in our standard form number 8, 1 upon s raised to n plus 1 its inverse Laplace transformation, where the value of n is 1. So we can write this as 1 upon 1 factorial t raised to 1, which is simply t. Now this third step says that replace t by t minus u. We can write this as t minus u, and this is the value of f2 of t minus u. f2 of t minus u. Now let's apply the fourth step, which is called as convolution theorem. So now by convolution theorem, we can write this as inverse Laplace transformation of phi 1 into phi 2 of s is equal to integration 0 to t, then this is f1 of u, then f2 of t minus u du. Now put the value of f1 and f2 and let's do the next step. We can write this as inverse Laplace transformation of product of phi1 and phi2 means original function. So we can write this as s square s plus 1 its square is equal to integration 0 to t. Now put the value of f1 of u. So value of f1 of u is e raised to minus u into u. Now put the value of f2 which is t minus u into du. Now our next step is to find out the integration of this term. So before finding integration, let's simplify this term. So we can write this as integration 0 to t, then this is e raised to minus u as it is. Then if we take this u to the inner side of this bracket, then we get this as ut minus this is u into u square du. So now this is the first term and this is the second term. So apply the concept of general rule for integration by parts. So now if we apply the general rule for integration by parts, then we can write this as integration of uv dx is equal to first function integration of second minus derivative of first second integration plus second derivative third integration and so on. So this is called as general rule for integration by parts. So here let's denote this as u and this as v, because according to the LIAPE property, so this exponential is the last function, that's why we denote this by v. So now friends, apply this general rule for integration by parts and find the integration of this equation. So now next step is integration. So we are finding the integration after applying the general rule. So we can directly write this step as which is equal to in bracket. So first term, so u means first term as it is. So this is ut minus u square, first term as it is, integration of second. So integration of e raised to minus u. So this is e raised to minus u upon minus 1. First function integration of second minus derivative of this function. So u dash, derivative of u is u dash. So derivative of this function with respect to u is, so this is t minus 2u. So this is t minus 2u into once again v2. v2 means integration of v1 here. So its integration. So we can write this as e raised to minus u upon minus become plus 1. So the next step is plus. So u dash u double dash, that means second derivative. So its derivative again with respect to u, its derivative with respect to u is minus 2. Then again, so integration of v2 which is v3. So its integration which is e raised to minus u upon minus 1 and its limit is 0 to t. Next derivative of this minus 2 is 0. That's why this is the last step. Now here limit is 0 to t. Now friends, first put the value of upper limit. Whenever we put the value of upper limit, write down one circular bracket. So we are putting this upper limit and lower limit for u. So now put the value of upper limit as t. So we get this as t into t square minus t square. So this first term is 0. Then this is minus. Then if we put u is equal to t, then we get this as t minus 2t, that means this is minus t. So we can write this as t into e raised to minus t. So then this is again minus minus plus 2 times e raised to minus t. So friends, this is the value of upper limit, one bracket, minus value of lower limit. We are putting this lower limit for u. So if u is equal to 0, this first term is 0. Then again here u is equal to 0, we get this as minus t, then u is equal to 0. So we get this term as 1. Then this is minus minus become plus, then we get this as 2. So this term will get over. This is the value of lower limit. Now just simplify this, we get this as t e raised to minus t plus 2 e raised to minus t, then this is again minus 1 will become plus t minus 2. So friends, in this way we get the answer to this question. So this is our example number 3. Now let's take the last fourth example. Now friends, let's discuss the fourth example based on this convolution theorem. So example is, so 1 upon s minus 2 s plus 2 its square. So now first step is to find out the value of phi 1 and phi 2. So first find out the value of phi 1 and phi 2. So now friends, we just discussed that choose the value of phi 2 where its Laplace transformation becomes simple. So because after finding inverse Laplace transformation of phi 2, we are replacing t by t minus u. So that's why choose the value of phi 2 so that its Laplace transformation become simple. So now here we choose the value of phi 2 as 1 upon s minus 2. Then the value of phi 1 is 1 upon s plus 2 its square. So in this way we will choose the value of phi 1 and phi 2. So this is our first step. Now second step is to find out the inverse Laplace transformation of phi 1 of s, which is inverse Laplace transformation of 1 upon s plus 2 its square, which is equal to. So according to the second method for finding the inverse Laplace transformation by second shifting theorem, so we are writing this as e raised to minus 2t into, this is inverse Laplace transformation of 1 upon s square. So moreover, we can write this as e raised to minus 2t, then this is Laplace transformation of 1 upon s square, means t raised to 1, value of n is 1. So now we can write this as e raised to minus 2u into u, and this is the value of our f1 of u. This is our second step. Now let's do the third step, find out the inverse Laplace transformation of phi 2 of s, which is equal to inverse Laplace transformation of value of phi 2 is 1 upon s minus 2. So which is equal to, this equation is in our standard form, inverse Laplace transformation of 1 upon s minus a is equal to e raised to at, where the value of a is 2. We can write this as e raised to 2t. Now we can write this as e raised to 2 t minus u, put bracket here without forgetting, so please note down your bracket, so to avoid the mistakes. So now we are replacing t by t minus u, and this is the value of our f2 of t minus u according to the step number 3. Now apply the convolution theorem. So if we apply the convolution theorem, so this theorem says that inverse Laplace transformation of phi 1 of s, phi 2 of s is equal to integration 0 to t f1 of u, f2 of t minus u du. So now here we directly put the value. So this is 1 upon s minus 2, then s plus 2 its square, which is equal to, we can write this as integration 0 to t, then value of f1, so which is e raised to minus 2u into u, and with f2 which is e raised to 2 times t minus u du. Now friends, next step is to find out the integration of this term, but here we are integrating with respect to u. Also parameter t is available here, so take the t outside the integration, so t become constant. So now we can rearrange this equation as integration 0 to t, then collect all the t term together with power e. So now we can write this as e raised to 2t, then again this is e raised to u term together, e raised to minus 2u, and this is minus 2u, that means e raised to minus 4u, this u as it is into du. So moreover, we can write this as e raised to 2u, sorry, e raised to 2t, e raised to 2t, integration 0 to t, then e raised to minus 4u u du. So now our aim is to find out the integration of this term. So now to find out the integration of these two terms, so this is the product of two terms. Whenever product of two terms is there, we are applying the general rule for integration by parts. We say that first function integration of second minus derivative of first, then integration of second plus second derivative, third integration, and so on. So friends, apply the general rule for integration by parts concept here, so to find out the integration of product of these two terms. So now if we try to solve this example with the help of this general rule for integration by parts, then we get next step as which is equal to e raised to 2t, then in bracket. So according to the LIATE rule, so this exponential is the second function. So we can write this as first function u, integration of second, integration is e raised to minus 4u upon minus 4, first function integration of second minus derivative of first, derivative of u with respect to u is 1, integration of second, this is e raised to minus 4u upon minus become plus 16 integration 0 to t, 4 for the 16 minus become plus. Now here friends, put the value of upper limit and put the value of lower limit. Upper limit is t, we can write this as e raised to 2t, then this is minus t by 4 e raised to minus 4t, then this is minus e raised to minus 4t upon 16, this is upper limit, one bracket, minus, put the value of lower limit is 0, so u is equal to 0, first term is 0, then this is minus 1 upon 16. So now friends here, so take the term 1 upon 16 common, or moreover we can write this as e raised to 2t, then this is minus t by 4 e raised to minus 4t minus, so this is e raised to minus 40 upon 16, and this is minus become plus 16. So in this way we will reach to the final answer to this question, or it may be possible to take the term 16 common. So now this is the fourth example, which is based on the convolution theorem. Now friends, we will stop here. So before concluding this lecture, let's take some example for your practice. Now friends, for your practice purpose, solve these 6 examples. So along with these 6 examples, answers are provided. So first example, so s square upon s square minus s square h square. So we can write phi 1 as s upon s square minus a square, and phi 2 as s upon s square minus a square. We can easily find the value of phi 1 and phi 2. So here take the value of phi 1 as s square minus a square, and value of phi 2 is 1 upon s. Now here we can write this as, so 1 upon s square plus 1, and this upon this term. So that means we can take the value of phi 1 is equal to s upon, this is s square 1, and phi 2 is equal to s plus 1 upon, this is s square plus 2s plus 2. So that after taking product of these two terms, we get original term as it is. So here we can get the value of cos term, but for finding the inverse Laplace transformation of this function, apply the shifting theorem and adjust this denominator term, so that we can easily apply the concept of shifting theorem for inverse Laplace transformation, which is our method number 2. Then find out its inverse Laplace transformation. Now here straightforward, this is the value of phi 1 and this is the value of phi 2. Choose the value of phi 2 in simple way, so that its Laplace transformation become simple. So now here again, this is phi 1, this is phi 2, no doubt. Then again this is phi 1, this is phi 2. So all 6 examples are given here. So please solve all these 6 examples and verify your answer with the answer provided by here. So this is called as test your knowledge concept. So this is the last part of this video lecture. Friends, I hope you like this lecture. So thanks to one and all for watching this lecture. Thank you.
me.